Welcome back to Beyond Classified. I'm your host, Chris Matthew. Tonight I want to welcome Ben Davidson. He is creator of the Mobile Observatory Project, suspiciousobservers.org, Observing the Frontier, spaceweathernews.com, magneticreversal.org, and quakewatch.net. Ben, welcome. How are you doing today?
All about as good as any other day here, given everything else happening on the planet.
Right? Yeah, we're living in definitely crazy times. Last time we spoke, it was about like 2 years ago, and we discussed the state of the sun, Earth, space weather at the time, and the possibility of seeing a major cataclysm within our lifetime. And, I can imagine that within 2 years, much has happened with our sun, the planets, and the solar system and our position in the galaxy in general. Let's start with a little update on our sun. Last time we spoke, we talked about how we were going into a solar minimum and that we could see some major effects possibly within the next few years. How's the old sun been doing lately?
Well, that solar minimum ended in 2020 in terms of the 11-year cycle. In terms of the longer cycle and what people call a grand solar minimum, that is still a very strong possibility to start in the 2030s or so, maybe the 2040s, and that will have pretty severe climate impact. But in terms of the sun's 11-year cycle, the shorter one, it is back on the upswing. It has started the cycle a lot more ferociously than a lot of people expected. And more concerningly, it's having some geomagnetic effects that aren't quite expected unless Earth's magnetic field was declining at the same, at the same kind of scary level, which it appears it might be, as weak space weather appears to have a strong geomagnetic effect on the Earth.
Now, a couple of things that I've seen, and I'm not sure if it's just me misremembering things, but when I look at the sun now, it seems like it's more white in color than it used to be, kind of like a bright white light bulb. And when I remember looking at it as a kid, growing up in the 80s and 90s, it used to seem like it used to look orange or yellowish. Is that just me misremembering things, or does the sun actually look different now?
Now, the sun absolutely does look different now, and that's also due to Earth's changing magnetic field, which by itself changes how the electromagnetic light that we see from the sun actually comes through. But that changing magnetic field is also changing how space energy plays with the layer in between the magnetic field and the atmosphere, called the ionosphere. It's playing with the upper atmosphere as well. And all of these things are, individual lenses, if you will, through which we view the heavens. And those are changing, at the electromagnetic level way out at the outer reach of the planet. It's a direct change on the light, and then the indirect change is based on how the ionosphere and atmosphere are being changed as well. And so that is one of the signs that things are happening. If people are noticing that they're getting sunburned more easily, or if they're having more of those sunlight sensitivity episodes where it's like, wow, I can't even open my eyes outside right now. I know not everybody has that ultra sensitivity to the light, but for those who do, they may have been noticing an increased incidence of them. It hasn't gotten to the point, obviously, where the insects and the flowers and the leaves are dying, but based on the magnetic data and some of the correlating reports from people all around the world, there's a lot of reason to think that, what I was mentioning before about the weak space weather, sort of like the tiny little guy gives a tiny little punch to the big bully, and somehow the big bully falls over. It's like that's what's happening with the magnetic field from little things with space weather. And it all sort of correlates with the idea that, hey, these things we're seeing, we're feeling, and we're actually able to notice in the data. And, of course, by seeing, I meant, you can see that the sun doesn't look the same. In fact, it's so bright up at the top of the sky, looks like it's wearing a crown. You can barely look at it.
Yeah.
To look over to the side.
Now, is there more radiation actually penetrating to the ground than usual right now?
In technically, yes, it's not the kind of thing to get scared about. The insects and the flowers and the leaves, those things will have, considerable effects, before it gets to the point where it's terrifying for humans and other things like that. There will be noticeable effects on the other parts of the atmosphere. That whole UV index is a big thing now. It's not just a guess. There's actual data it's based on, and it's a robust enough thing, and enough people have home detectors and other things like that. It's like a personal radar you can get, but a personal UV thing. The moment things get scary, everybody in the world's going to know.
Right. Now, when I look at satellite images of the sun, there's something else that I've noticed, that the poles of the sun seem darker now than, I don't know, maybe 10 years ago or so. Is that actually something that's a thing, or is that just me misnoticing something as well?
So if you look back exactly 10 years ago, I'm have to think back because the polar coronal holes were starting to reverse at that point. And if you look in about 2 months, a lot of the darkness that you've been noticing at the polar region of the sun will be starting to migrate towards lower and lower latitudes. That's part of the solar magnetic reversal that happens every 11 years and triggers that sunspot cycle. It makes it go from that calm, quiescent looking thing to having the sunspots and creating the huge solar flares and the coronal mass ejections, which could potentially send us back to the Stone Age. It's quite the thing that happens on the sun every 11 years when its magnetic fields reverse. And so when the sun is very quiet, those coronal holes, the things that look dark in the ultraviolet images that you were referencing from satellite, those mostly hang out at the polar region. And even when they start to migrate, there is still smaller coronal hole activity at the poles. It's harder to see from those satellite images, which are pretty much taken from the equatorial, heliographic latitude. So you don't get exactly to look down on either of the polar regions. But it is a moving thing throughout the cycle. And right now we are still seeing it beginning, but the solar magnetic shift is starting. And I would say that if you pay close attention over the coming weeks and months, you're going to notice less of that darkness at the poles and more of it shifting towards the solar equator.
Now, is this going to be creating more sunspots and possible CMEs from the sun as this occurs?
Right. That's what's really happening right now. One of the things we see is the coronal holes want to go from the polar regions towards the equator, and eventually they'll cross over and switch places, indicating the magnetic shift of the sun. But while that is going on, it creates such a disruption to the sun that's what triggers the formation of the sunspots. It's all based on the magnetic changes. The sunspots are electromagnetic things. It's really just a magnetic mess when this happens every 11 years. And yes, we do expect more of the sunspots and the solar flares and those plasma eruptions called coronal mass ejections, or CMEs.
Now, I do want to get to some of the effects that we could possibly see on the Earth, but the sun, of course, affects all the planets in our solar system. Are there any other planets in our solar system right now kind of experiencing these major changes, or anything that would indicate the activity changing on our sun and in our solar system?
Well, right. I'm not sure exactly how much we went over the last time we talked, but if it's been about 2 years since we talked, back then we did already know that Venus' fastest winds were getting faster. To give you an idea, Earth's fastest winds have been getting a little bit faster, but we're talking like 1%. Venus' fastest winds increased 33%, and they're starting to question what its rotation speed actually is. Mars was heating up faster than the Earth was during the majority of the period known as global warming. But also, since they've landed InSight on Mars, they've noticed that the quakes there are increasing in number, frequency and in magnitude, and they don't have a good explanation for why that is. On Jupiter, we have seen a number of atmospheric anomalies, but most notably, we have seen the radio emission change at Jupiter, and the radio emission is driven by electrons caught in its magnetic field. And since we're presuming that the nature of an electron didn't just decide to change at Jupiter, an electron's still an electron, that means that its magnetic field changed. We have seen a number of great anomalies at Saturn, and its rotation has come into question as well. And I believe we had seen the record storms and auroras on both Uranus and Neptune when we had last talked. But since then, a number of important key updates have happened. One, they noticed that Pluto's atmosphere collapsed. Basically, what happened to Mars, what people worry about happening to Earth if we get hit by a big eruption from the sun while our magnetic field is in the process of reversing, that terrible coincidence. It lost 20% of its atmosphere in 1 year. Initially, they were saying, we have this data from 2016 and 2019, and it looks like they lost 20% of their atmosphere there at Pluto, which is, still a preposterous amount to lose in 3 years. And then the long-term processing data from Hubble came back from 2018 to show that at that point it hadn't lost that atmosphere yet. And so it happened at some point between 2018 and 2019. And really the only way you get that is some kind of major catastrophe. We know that Pluto has some magnetism. How much of that is intrinsic versus induced by the solar wind, we don't know, but it has some protection. But if that failed, it would have, especially during a coronal mass ejection, it would have a major mass loss event in terms of its atmosphere. On Neptune, Neptune is very, very predictable storm patterns, except they just reversed. So kind of like how we know that hurricanes form off the coast of Africa and then they run across the Atlantic and they either peter out or they go into the Caribbean or the Gulf, or maybe sometimes they even run up the east coast of the United States. But it's not like they form off the coast of New York and run southward past Florida and then east across the Atlantic towards Africa. Well, something like that just happened on Neptune. And you don't get something like that without an unbelievably catastrophic change in the processes of how the planet's dynamics actually work. We're going to have a really good chance to look at Mercury here when Bepi Colombo arrives. Mercury Messenger made some measurements of its magnetic field. And when Bepi Colombo arrives, it'll be able to do the same, and it'll be the first before and after real data we have on Mercury. And that Mercury is really the last planet left we have to look for this, with the exception of the central node of the system. And the sun actually began to show some signs that it's having its much greater change as well. Said to be driven by changes in, again, its magnetic fields. They are noticing a helium density change in the corona, which is the sun's atmosphere. And this is one of the key changes that we're looking for in terms of what's going to precede the greatest of solar blasts, which unfortunately it looks like we're due up for that cycle here. Within my lifetime, put it that way. I'm 36.
Wow, yeah, that is really interesting and kind of concerning at the same time. I have a couple of questions from Laura Wells News and Astronomy. She asks, with the depletion of our protective shield, how long do you think we have until our crops will actually be much harder to grow because of the radiation?
It's an interesting question, and it's really hard to say. Up until the point where it crosses the threshold of harmful, in theory, you should be seeing an increase due to the UV if it hasn't quite hit that threshold of harmful yet, because technically, UV helps them make their food. What we know is that the magnetic field most recently peaked in strength about 3,000 to 5,000 years ago. We know that it didn't really do a whole lot up until about 1859. I mean, maybe we lost 1%, but let's just say the field was at about 100% at 1859. Well, perhaps coincidentally and perhaps not, the only super flare of the sun during the technological age occurred during the 1859 year. Luckily, there wasn't much to destroy. It did do a number on the telegraph wires that did exist, shocked operators that were using them. They unplugged the machines and messages kept transmitting. Wires caught on fire, melted, things like that. And at that same time, Earth's magnetic field began to change rapidly. Not only the magnetic poles began to shift, but the strength began to weaken. Now, up till about 2000, so 1859 to 2000, we lost about 10% of the field. They updated that number to 15% in 2010. And so that basically means that after about 150 years, they lost 10%, but lost 5% more in only a decade. Now, we've had word that there were accelerations in 2015 and 2017, but they have not given us new percentages down. They have not mentioned how much faster things have increased, with the exception of a note from the now former head of the magnetic monitoring mission from the European Space Agency called SWARM. His name was Rune Flobergagen, and it's as cool of a name as that is. What he told Science Alert back in 2014 or 2015 was even more interesting. And he said, basically, Earth's magnetic field has gone from losing 5% of itself about per century to losing about 5% per decade. And that is really a concerning thing when you look at the fact that we had further accelerations in 2015 and 2017. There is another geomagnetic jerk due up here at some point, and we may have had another acceleration in 2020, if indeed the geomagnetic jerk that was expected occurred during that time. But the field is appearing to weaken much faster, and given the fact that they haven't given us the data, a lot of it is a guessing game, and a lot of the only things we can do is actually look at the Earth and the other planets and see how fast they're changing. Now, the best data comes from the Earth, of course, and so when you get things like record lightning in the Arctic and record bolts in other places of the world, while they're blaming climate change, you also have to realize that the Arctic is the North Polar cusp. That's where that solar energy chooses to go in. It's where it prefers to go in. We're going to be seeing a lot more on that. And if you try to look at some of the papers on, the solar energetic particles or cosmic rays in general triggering lightning, that scientific field has exploded, and pretty much all questions and doubt about the correlation are gone. Or you have to look at the actual space weather effects to the magnetic field. What I was describing as, the little wimpy guy giving a little slap to the belly button of the bully and he somehow falls over. We have a pretty good idea of what these coronal mass ejections should be doing to Earth. We can judge it based on the size of the eruption that we can see. We can track the speed with the satellites of how fast it's going. If there's a flare associated, we can see the energy level of the flare and get a little bit better idea about the energy of the eruption. But as happened in 2015 with a video I made, and I made a video detailing the entire situation. It's a video called How Close We Came. Basically, relatively weak space weather was able to take us to the brink of losing major grids back in 2015. And then it happened again in 2017. And this time, the peer-reviewed journals were waiting for something like this to happen. I saw literally dozens of papers that have come out since that happened, describing how unexpected this was, how there wasn't really anything in the data to suggest that this disruption magnetically to our planet should have been so large. And we just got the first test of this sunspot cycle. We mentioned that the sun is now starting to wake back up. Well, in its waking stretches and clearing its throat, it popped a little one at us last week. And I do mean a little one, but it caused a strong geomagnetic storm. In my forecast, in NOAA's forecast, NASA's forecast, literally everyone was predicting a low-level storm. But then again, they were also predicting the impact to be a bit stronger than it turned out to be in the data. And so the data actually said, ooh, this storm was a little bit weaker than we thought. And yet all of the data shows our magnetic field took a complete whack. The little wimp hit us in the belly button and we tripped over our shoelaces, fell and broke our back. Now,
Right.
of course, that's perhaps an overstatement because the magnetic field is, of course, not broken at the moment. But it was very disconcerting. It was not what you wanted to see as the very first test right off the bat, as the sun is waking up to greater and greater activity over the coming 2 to 4 years. It was not a good sign.